All right, guys, can you guys hear me? All right, so maybe let's give it one more minute while we're receiving more attendance. Okay, today is the new lecture. Today is lecture number 1 of our new session, so we might have some new students. So let's give it maybe one more minute while we're receiving more attendance. Okay. All right, it's 7:01, so let's get started. Okay, so today is the lecture number 1 of our session number 7. This is going to be our knowledge-based lectures. Compared to our Euclid bootcamp, in this lecture, we're going to be more focused on the detailed concepts, strategies, knowledge base, so on and so forth, on a specific topic, rather than like Euclid, right? We basically use one lecture to cover the entire topic. For now, on the contrary, we're going to use 10 lectures to cover 1 or 2 topics. Okay, so before we get started, let's have a quick preview what will be covered in our current session. Our current session has a name, it's the inequality and polynomial. So it basically speaks for itself. So in our current session, we're going to cover 2 major topics. One is inequality, while the other one is polynomial. So what we need to cover in these 2 topics, in these 10 lectures, for the inequality part, we're going to start with some inequality basics, okay? This is pretty much what we're going to do today. Basic concepts. We're not talking about any flowery inequality like Chebyshev, Cauchy, so on and so forth. Just like the basic definition of inequality that you see the problem, how you're going to deal with all those problems in different kinds of math competitions. And then we're going to go to our mean inequality, which is extremely important for all the math competitions. Inequality is a big concept, and mean inequality is actually the foundation. Most of the theorems, the conclusions are actually elaborated from the mean inequality. So therefore, have a good understanding for the mean inequality will be crucial. We're going to spend some time teaching you guys how to deal with the mean inequality related problems. What are the strategies? What are the common tricks? So on and so forth. And then moving forward, we'll go to another very important, what we call is the Cauchy-Schwarz inequality. Cauchy-Schwarz inequality is also very important for high school math competition, because a lot of problems, if you cannot solve it using mean inequality, your number 2 trial is going to be the Cauchy-Schwarz. So I'll say, generally speaking, mean inequality and Cauchy inequality takes roughly 60% of most of the inequality-related proof. So therefore, have a good understanding for these 2 major topics are crucial. We're going to spend some time teaching you guys how to deal with these 2 very important inequalities. And moving forward, we're also going to introduce some advanced inequalities, something like the Chebyshev, Jensen's, triangular, Holder's inequality, so on and so forth. Why I would like to introduce this part? Because trust me, inequality is one of the most complicated part in the algebra. If you go to the National Math Olympia, for instance, USAMO, CMO, or even the IMO, you're going to find out inequality takes a major part of the algebra problem in this high-level math competition, because it is so easy for the author to create some crazy problems to give you guys a super hard time. So that being said, that's the reason why we like to put more time for the inequality, especially give you guys more advanced inequalities, advanced prototypes. That's going to help you do a very good job in the complicated high-level math competition. Okay, and also we're going to talk about some proving strategies for inequality. Inequality is difficult. Not only it has so many formulas, so many conclusions you need to remember, but also to prove an inequality problem, you need so many strategies. For instance, the construction method. For instance, the scaling, the normalization, the comparison, so on and so forth. These are the very typical method which will be used to solve typical problems. So at the end of the day, what we want to see is that as long as I give you an inequality, you will automatically have a conditional react, find out a specific method, try to solve the inequality. So this is basically what we try to train you guys at the end of our lecture. And moving forward, we're going to talk about the inequality and its applications. So this is going to cover the majority part of the inequality, which is the major part of our session. And then moving forward, we're going to go to another very important topic, which is the polynomial. Polynomial is also a very important concept. At least this is not something so unfamiliar for most of the students, right? We learn the quadratic equation, we learn the linear equation. They're all considered to be a specific type of the polynomial. So we're going to start with some polynomial basics, which is very understandable. And then we're going to go to the roots and the relationship between the roots and coefficient. Everyone knows that that's going to be our WECHAT formula, right? We learn the WECHAT formula for the second order, and I think most of you guys know it for the third order. We're going to make it more generic, right? The higher order polynomial, what's the relationship between the coefficients and the roots, and how to use them in a more flowery way. Moving forward, we're going to talk about the polynomial function, and again, different strategies, how to prove the polynomial related problems. Right? Fish and fishing, understand the strategy is way more important than keep giving you guys different problems. And then moving forward, we're going to talk about a fundamental theorem in algebra, which is very important for polynomial, especially when we're not only focused on the real domain, especially we go to the complex domain, the fundamental theorem will be more important, will be more, what should I say, attractive as long as you see like an expanded domain of your solution. And also we're going to talk about some applications for the polynomial functions. So this is kind of like a quick forecast, what we will be talking about in our 10 lectures. Okay, if all good, let's fly to our lecture number 1. Let's talk about some basic concepts, properties of the inequalities. Okay, that's going to be our lecture number 1, inequality basics. Okay, again, as the name speaks for itself, inequality basics means the basic concepts of the inequality. We're not talking about anything flowery, anything complicated. You need to remember just are the basic properties. I think this is a very straightforward lecture. Most of you guys should already know most of the concepts. So let's get started. Number 1 is like so easy. It's a symmetric property, right? A is greater than B equals to B is lesser than A. And also this is what? You can pass on. A is greater than B, B is greater than C, so therefore A is greater than C. You can pass on these inequality properties. And this part is basically whenever you have like an inequality, you add the same number on the two sides of this inequality, the inequality keeps the same, right? Whenever you have two inequalities, A is greater than B, C is greater than D, these two inequalities you can add as long as they're facing to the same direction, they're both greater than, you can add the left, add the right, right? So the inequality property will still be held, which is quite understandable. Here, A is greater than B and C is greater than 0. So therefore, as long as you multiply a positive number on two sides of this inequality, the direction of the inequality will keep the same. However, if you try to do exactly the same thing, but you want to multiply a negative number on two sides of the inequality, the direction of the inequality sign is going to be changed. I think this is a huge difference between the equation and the inequality, right? Because for equation, you don't care, add, subtract, multiply or divide, do some division, everything keeps the same. However, when you're dealing with the inequality, always you want to bear in mind, this guy, if it is positive, everything keeps the same. If this is negative, everything will be flipped. I think you guys know that from day 1, right? So moving forward, again, the same thing, two inequalities, they have the same direction and both of them are positive. Of course, you can still multiply the two sides of these inequalities together. And then inequalities, as long as they're positive, you want to do some multiple powers, right? Different powers is going to be pretty much the same thing, which is exactly the same thing as we derived from our property number 6, right? I think this is something quite understandable. As long as you see something, the power thing works, then what about under root, right? This is very intuitive. If you have two, A is greater than B, and they're both positive, if you want to take the under root and left, right, the two sizes, the direction of the inequality will be exactly the same. These are all so easy peasy properties. You guys know that from day one, I'm pretty sure. Then moving forward, sometimes in the inequality problems, you like to take the reciprocal. A is greater than B, greater than 0. If you want to take the reciprocal, okay, you're going to change the direction of the inequality, right? This is also something we like to talk about from day one. Okay, moving forward, number 10 is actually a very important concept that I think most of the students already know that. And please bear in mind, AIME love to test it from time to time. That being said, if I have A is greater than B, which is greater than 0, and I have a positive number. So what's going to happen is that if you want to have B over A, okay, A is greater than B, right? So B over A will be lesser than 1. Right? So B over A will be lesser than if the denominator and the numerator, they both add the positive number. And this guy will be greater if B and A, the numerator and the denominator, they both subtract a positive number. Okay, this is basically you're dealing with B over A, which you have the fraction number lesser than 1. Then what about A over B? Because A is greater than B, A over B will be greater than 1, right? A over B's property will be exactly different from the B over A. As long as you want to add two positive numbers, for the numerator, for the denominator, A over B will be greater than that. Previously, B over A will be lesser than that. Same thing, if you want to subtract the same positive number from the numerator, from the denominator, A over B will be lesser than that. Previously will be greater than that. I don't think you need to remember this, right? This is too complicated, but at least from time to time, as long as you're given a fraction number, you want to subtract or you want to add something from the denominator, from the numerator, try to find out some numbers, do a quick calculation in your head, and then you will be able to see such a relationship. So trust me, these are so easy, but AIME, they love to test it from time to time as a very basic but useful property of the fraction numbers and also inequality. Okay, I think this is very understandable, even though you don't remember it, but you can just derive it right away. Okay, let's continue. So the first 10 parts will be the basic properties, right, of the inequality. And then let's talk about something, not only inequality, also you have some interaction with the functions, because inequality also they get tangled with the functions. So the first one we would like to talk about is, what about you have under root fx greater than gx? If the question asks you to solve this inequality, aka to find out x which meet such a relationship, what are you going to do? You're going to basically do some casework, because the left-hand side will be always non-negative. The right-hand side can be positive, 0, negative, so on and so forth. So that one, of course, you're going to do some casework. If gx is lesser than 0, okay, so as long as you want to have fx, which is the domain, right, the domain of under root fx, you can make sure this inequality always hold. Or if gx is greater or equal to 0, what you're going to do is you're going to have the perfect square on the two sides of this equation, which is quite understandable, right? Same thing. What about I have fx? I take the under root lesser than gx. So lesser than gx, I don't think you need to do the gx lesser than 0 or equal to 0 thing, because this is not going to give you any solution, right? Because under root fx will be always greater or equal to 0. So if gx is less or equal to 0, of course, there's no solution, right? So you don't need to even talk about it. The only solution for this is gx is greater than 0, fx need to have the basic definition, the domain, which is greater or equal to 0, and also you make a perfect square. Okay, I think these are very basic things you learn that from day one. But I just would like to put all the knowledge together, give you guys kind of like a summary, right? That you know where you come from. Moving forward, if fx times under root gx, okay, greater or equal to 0, either if you have gx equal to 0, means that fx, you don't really care, right? As long as gx is equal to 0, the equation, the inequalities always hold. Or alternatively, you have gx greater than 0 and fx greater or equal to 0. I think this is something quite understandable, right? So these are the basic casework when you're dealing with the inequality related, these equations or solve the inequality, so on and so forth. Okay, we talk about this kind of under root thing. We also want to talk something about this fraction. What about fx over gx is greater than 0? So that being said means, of course, gx cannot be equal to 0 as gx is already in the denominator. So that one is exactly the same as fx times gx greater than 0, right? This is quite understandable. So that being said, you can see sometimes some properties are exactly working for equations, but it won't be working for inequality and vice versa. Let's say for equation, right? If you have something greater than equal to something, of course you cannot multiple, right? You have to remove the gx from the two sides and then moving the term, so on and so forth. But from the inequality, fx over gx greater than 0 is the same as fx times gx greater than 0. These are the tiny differences between the inequality and the equation. And this one we want to say, what about fx over gx is greater or equal to 0? So as long as you have this equal, you need to do a quick analysis. Either you do the same thing and you need to have gx that's not equal to 0, right? Because you can let fx equals to 0, it doesn't matter. But gx in the denominator, so there's no way for gx equals to 0. Right? I think these are very basic things where this is like a high-level lecture. I don't want to expand too much. You guys should already know that, right? We just take this opportunity to summarize this basic stuff together to give you guys an idea. Okay? Okay, so let's continue. In these 4 different things, 1, 2, 3, 4, we want to talk about a very important concept for the inequality, which is absolute value inequality. Absolute value inequality, aka the inequality has some absolute value, absolute signs here, right? So let's talk about how we're going to deal with the absolute value related inequality problems. So number 1, fx absolute value greater or equal to gx. So that being said, you have to make sure fx is greater or equal to gx, or fx is less or equal to minus gx, which makes sense, right? This is something what we know from day one. If you have something absolute value greater than something, you want to take the 2 parts, right? This is minor gx, this is positive gx. So what's going to happen is these 2 parts, right? These are actually the solution for fx absolute value greater or equal to gx. Then what about less or equal to gx? So that part, I think everyone knows that as well. Greater is on the 2 sizes, right? Lesser is going to be something in between. So this is going to be your lesser than gx solution, which makes sense, right? You already know that. Okay. Also, from time to time in the math competition, they're going to ask you something like this. X minus A plus X minus B greater or equal to C or lesser or equal to C. This is also something you want to see that from time to time. So as long as you see such a problem, so my suggestion is try to use the definition of absolute value, and you will be able to solve the problem fairly quick. Because this one is not very straightforward, I'm going to give you two examples rather than using A, B, C, D. Might drive you a little bit, like confusing. So let's give you a real problem with the real numbers. If you understand these two quick examples, then you will understand the entire problems. So the first example will be try to find out the solution for such an inequality. Solve the inequality x minus 1 plus x plus 2 greater or equal to 5. Okay, so here we see sometimes you want to have greater than, sometimes you want a lesser than. Let's go for the greater one first. Okay, how to find out a solution for such a thing? So some student might say, maybe I'm going to take a perfect square on the left hand and the right hand, and then take another perfect square. So therefore, you'll be able to remove the absolute sign, right? I think that's a perfect solution, but that's going to involve a lot of calculation, right? Solution one may be perfect square. Okay, take perfect square and then take another perfect square. I'll leave it to yourself. Let's go for the second solution. Instead of doing the crazy calculation, how can we use the definition of absolute value and try to solve this inequality? So who can tell me what is the definition of this guy? This is more like a mathematical language, right? So can you transfer from this mathematical language, translate from this mathematical language more into a human language? What does this human language mean? Who can tell me? You can always type or unmute yourself, right? There's a lot of interactions in our lectures. Who can tell me, what does it mean? From a mathematical perspective, how can I convert it into human language? What does this mean? So somebody mentioned these two both smaller than 5. Okay, yeah, that makes sense. Yeah, of course, they're all positive, right? At least the non-negative. Their sum is greater than 5, so they must be all okay. Michael mentioned the left side is always positive, which is greater or equal to 5. Yeah, makes sense, right? But still, this is more like a mathematical language. So who can tell me what is the human language? Try to use the definition of absolute value. What does it mean? I'm going to ask Hansen.
Because absolute value, like definition, is like it distant from 0. So it really is like x distant from 1 plus x distance from -2 is greater than or equal to 5.
Is that right? I think that's a very good explanation. So that using the definition, you're trying to find out the points on the x-axis such that this point, the distance from this point to 1, 0 point, plus the distance from this point to -2, 0 point. You want to make the sum of the two distance greater or equal to 5. Is it right? You want to find out the points such that the distance from this point to -1 to 1, 0 plus the distance from this point to -2, 0. You want to make the sum greater or equal to 5. Which is understandable, right? There's nothing too flowery. So let's have a look at it. So let's have a look at it. How does this one works? I have this, okay. I want to have, this is like positive, this is -2, 0. This is positive 1, 0, right? So let's have a look at it. You want to make sure the distance between the point to -2 and positive 1, adding them together is greater or equal to 5. As long as my point is here, between -2 and positive 1, the distance will be always 3, right? It's the fixed. To the left, to the right, is the distance between -2 and 1. As long as my point come to here, okay, the distance is getting bigger, 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 right? Who can tell me at the reach point in my green area, okay? So I'm gonna show you. Maybe I'm gonna use, this is my green area. These are my blue area, right? Okay, in my green area, reach point can make sure the distance from that point to -2 plus the distance from that point to positive 1 exactly equals to 5. Who can tell me? I'm going to ask maybe Paul.
-3, 0.
Is it right? Very understandable, right? -3, 0. I'm going to use this color. -3, 0. So as long as the point is here, I can make sure the two green lines, the two green segments, adding them together will be equal to exactly 5. But now the question asks me greater or equal than 5. So therefore, as long as you are on the left-hand side of -3, 0, you're going to have exactly what you need. Okay, fairly easy, right? But now I only covered the green part, the blue part. So therefore, intuitively, I want to go for the yellow part. Who can tell me which point on the yellow part can make sure the point to -2, 0 plus the point to 1, 0, the distance sum is going to be equal to 5. Right? The entire thing is very symmetric. I'm going to ask maybe Tanya.
2, 0.
Is it right? 2, 0. So that being said, this part will be exactly equals to 5. So as long as you have something here greater than 2, 0, then you will have the value greater or equal to 5. Okay, so basically the solution will be x greater or lesser or equal to -3, or x greater or equal to 2. So that's the solution for such an inequality. You see, fairly understandable, right? We're not using any complicated calculations, so on and so forth. Just try to use the definition and you get what you need. So far, so good? All right, if all good, let me give you another example. I'll be asking you guys to tell me the answer. Exactly the same thing, because here we talk about positive or negative, like greater or lesser, right? So here we already talk about greater. Let's do a lesser one. Let's say let fx equals to x minus 1/2 absolute, x plus 1/2 absolute. Please find out the solution for fx lesser than 2. Okay, exactly the same thing. Who can tell me how to solve such an inequality? I'll give you guys maybe 2 minutes. Okay, when you're done, post your answers into the group chat. Please, everyone, if you're done, try to post your answers into the group chat. Okay, this is a very basic concepts. Everyone needs to know this. Yeah, I see many students have it correct. So this time I'm going to ask for maybe Michael. How did you solve such a problem?
So using the same method of drawing the line, so you have the points -1/2, 0, and 0.1/2, 0. So, and then you just, what's it called? And I found out that distance is 1. And then the 2 points that are, like kind of like the smaller, something. So it's 1 and -1 that are the 2 points outside. And it has to be smaller than 2. When you plug in -1 or 1, it will equal 2. So it has to be, x has to be smaller than 1 or larger than -1.
Is it right? Yeah, I think that's pretty much the same process. Michael make it very clear. So again, as long as you say this, you're going to find out there's 2 points, right? Basically mark it on the x-axis. So as long as you're here, anything between -1 or 2 or +1 or 2, the distance sum is going to be always 1, which is okay. But as long as you're getting a little bit on the left, let's say when you're hitting the point -1, so this part plus this part is going to be exactly equals to 2, right? If you get a little bit more on the left, the value will be greater than 2, right? Which makes sense. The entire thing is exactly symmetric. As long as you come to here, +1, the distance from here to here, the 2 green lines, add them together, is going to be equal to 2. As long as you're getting a little bit more on the right, again, the value will be greater than 2. So that being said, with everything that follows between from -1 to +1, you would make sure the distance between the point to +1 or 2 plus the distance between the points to -1 or 2. The sum is going to be lesser than 2. So the solution will be x -1, +1. Is it right? Easy peasy, right? There's nothing flowery. We just use the basic definition and you are good to go. So trust me, this is very important, not necessarily give you a big problem, but during the calculation process, the question might ask you a little bit here and there, just try to ask you to determine something and you are good to go. Okay, so this is what we talk about here. Try to use the definition and you will be able to solve these kind of problems. You can actually expand this to multiple, right? This is only 2 absolute value signs. You can have 4, 5, 6, 7. You're going to do the same thing, right? Okay, let's continue. And the last one is actually something very important. People use that from time to time, is the absolute value inequality. Most of the time when you say the absolute value inequality, you mean the last one. A plus B or minus B's absolute value will be always greater or equal to A absolute minus B absolute, and always lesser or equal to A absolute plus B absolute, which may make sense, right? So the only condition for these 2 equal signs to be achieved, sometimes this AB has the same sign, sometimes this AB has the different sign. right? You'll be able to figure them out during your calculation. But generally speaking, the only thing is A times B greater than 0 or A times B lesser than 0. That's going to help you to achieve the two equal signs on the left or on the right, right? I think this is something very understandable. The last part I want to talk about in the basic inequality properties is how to solve this quadratic inequality, right? I know everyone knows that, but just want to take this opportunity to have a quick summary. If you have a quadratic inequality, right, it's a quadratic equation. And of course, you're going to have your delta value. And how to see, let's say this one is greater than 0, lesser than 0, exactly the same thing, greater than 0. So how to solve it? Delta greater than 0, delta equals 0, delta lesser than 0. A is greater than 0, A is lesser than 0. So, this time, I really want you guys to never, ever remember anything. It's too complicated to remember everything. You can try to use the graph. And then you will be able to solve it so easy. Let's have a quick look at it. If I have a quadratic equation facing up, A is greater than 0, facing up, you have delta greater than 0. Then you have something like this, right? The question asks you, what are the range of x to make sure ax squared plus bx plus c is greater than 0? For sure, all these parts, right? They will be greater than 0. So this is going to be your x1. This is going to be your x2. As long as x is greater than x2 or x is lesser than x1, you will have the value greater than 0. So easy, right? Then what about my a is lesser than 0? My a is lesser than 0, my quadratic is goes like this, right? Delta greater than 0 means there are two intersection points with the x-axis. A lesser than 0, the quadratic is facing down. So where you can have the value greater than 0? Of course, x1, x2, as long as you have x between x1 and x2, you have such a thing. Right? No need to remember greater than, I need to blah, 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 lesser than, I need to blah, blah, blah. Try to use the graph. Everything is already in the graph. We don't have to remember so many weird things. Okay, second one, what about my delta is equal to 0? My delta is equal to 0. Again, if my a is greater than 0, you have something like this, right? The tangent, right? The parabola is tangent to the x-axis. And you want my value is greater than 0. So you can take anything except my intersection point. My intersection point at this moment is going to be the vertex, right? The vertex of the parabola. So as long as this is not equals to the vertex, you'll be able to, good to go. See, here is not equals to. Then what about my a is lesser than 0, right? My parabola is facing down, and you also want my value to be greater than 0. Unfortunately, nothing. There's an empty set for this solution. Okay, last one, my delta is lesser than 0. My delta is lesser than 0. What about my a is greater than 0? That's my x-axis, that's my parabola. There's no intersection point. You want my value greater than 0? Of course, all the x's will be basically make it greater than 0. So x belongs to R. Same thing, when you have something like this, a is lesser than 0, the parabola has no intersection point with the x-axis. There's no solution to make sure your value is greater than 0. So therefore, it's an empty set. That's it. Like I said, so easy peasy. There's nothing you need to remember as long as you know the basic concepts of the graph, how the parabola function looks like. That's going to be your solution. So far, so good. I think it's something very understandable, right? Perfect. If all good, so let's talk about for this basic inequality problem. Inequality basics. In this part, again, we're not talking about mean inequality, Cauchy inequality, Chebyshev, just a basic definition of the inequality. What are the major problems you're looking at? Generally speaking, from our Canadian exam, from the American exam, generally speaking, you're looking at 3 types of problem. Type 1 is kind of like some calculation. I give you some inequality, and then I ask you to, based on the inequality, based on the property of the inequality, do some calculations. Sometimes maybe you need to solve some inequality. Sometimes you want to determine the value of a parameter, but nothing, just calculation. That's it. The second part is absolute value inequality. Like I said, absolute value inequality is a special part, right? We spent some time, it's a special part. And there are some problems testing you the absolute value inequality. And generally speaking, the strategy for you to solve the absolute value related inequality is using the definition. You need to understand what is the physical definition, what is the geometric meaning of such an inequality. Using the definition, the distance from one point to the other, so on and so forth, that's going to help you to solve the problem. Okay. And the third part is actually a little bit vague. You have to do some construction. So construction, what is construction? Construction, you know, the word speaks for itself. Construction means you create something from nothing, right? Like our builder, right? We construct our properties. So construction is create something from nothing. So, but the most important thing is how you want to create something. Sometimes the question gives you a weird expression. You have totally no idea what to do. However, as long as you can construct some specific scenarios, some background, you can very smartly solve the problem using very easy peasy strategies. So this is basically where our construction comes from. So construction, I always say, construction method handles like a dream. Just keep you one step away from the correct answer. But the million-dollar question is, how can I do the construction? And this is actually a million-dollar question for this entire inequality. Today, I'm going to give you some kind of like a pre-taste, like a preview, kind of like a taste, how this one works like. And then this entire lecture, our entire session is going to be teaching you guys different ways how to do the construction. So don't be too rushed. Gradually by gradually, I'll teach you guys different methodologies, different scenarios, how to do the construction. But today, let's give you some easy peasy examples. Let's have a look at it, how you want to start your construction. So these are basically the 3 major problems you're looking at, okay? And afterwards, I'm going to give you some real problems. Try to use the real problem from these 3 different categories, try to see how it works in the real life. Okay, if all good, let's go to our category number 1. Just do some quick calculation thing. Calculation related problem. Let's go to our number 1 problem. This is a problem from 2011 AMC 12A, question number 20. So I'll give you 30 seconds, read the problem first. And then we're gonna do some discussion together to see how you wanna think for such a problem. All right, let's try to read the problem all together, okay? The most important thing is I want to show you guys how you read a problem. What are the action words, right? The buzzword. As long as you see some buzzword, what are you going to do? What is the conditional react? Conditional react is the key thing we're going to talk about in our entire lectures. So let's read it first. We let fx equals to ax squared plus bx plus c. It's a quadratic equation where a, b, c, they are integers. Okay, let's try to highlight it. Integers, because if I give you a quadratic equation, a, b, c, they're the coefficient. A, b, c do not have to be integers, right? Something do not have to be integers, but you say they are integers, there might be some reasoning. Okay, I have to highlight it. Suppose that f1 equals to 0. Okay, f7 is between 50 and 60. f8 is between 70 and 80. Okay, f100 is between 5,000k and 5,000k plus 1 for some integers. So what's the value for k? Okay, so before we jump to the solution A, B, C, or K, whatever, I think intuitively, you need to convert your condition, right, given by the problem into some expressions, and taking from there, hopefully you can do something, right? I think these three conditions are very conspicuous. I need to put them into an equation, right? f1 equals to 0. That being said means a plus b plus c equals to 0. Okay, and then f7 is between 50 to 60. That one being said is 50, 49a, 7b, c lesser than 60. And then the last one is 70, 64a, 8b, c lesser than 80, right? These are the three conditions. At this moment, I'm not even doing any kind of calculation or thinking. I just convert whatever the question asks me into three expressions. So the next question I'm going to be asking you guys. From here, intuitively, what is your next step? I'm not saying how to solve this problem, right? I'm just saying, as long as you see the three expressions here, intuitively, what you need to do. Please post your answers into the group chat. I'm going to ask maybe Wayne.
So you have a plus b plus c equals to 0. So if you subtract this equation into the other two inequalities, the right side and the leftmost side is not going to change, but you can cancel out c.
Is it right? I think that's a very important approach, because now you have three equations. I mean, one equation, two inequality, right? Three kind of like things. And then you have three variables, A, B, C. You don't want to deal with like too much variables, right? You want to reduce the variable. Of course, you want to reduce the variable, right? So which variable is easy to reduce? Of course, C. You see, C is always like only single C. A and B, they have this weird coefficient, right? Of course, if you want to remove A and B, of course, it still works. But I think C is very understandable. So intuitively, you want to do some substitution, right? C equals what? Minus A plus B. I'm just going to drag it here. I'm just going to drag it here. I have no idea how that one works, but let's have a quick look at it. At least I reduce the one of the variable, right? This is a common sense. Too much variables, I can do nothing. So I'm going to plug them in. So I'll have a look at what's going to happen. Let's go to the first one. The second one, Is it right? I just basically do a quick substitution. Here, let's think about it. Generally speaking, I only have like A and B. They're like two ranges, right? I shouldn't get too much of this information. However, don't forget, there's a very special condition given by the problem, aka A, B, C, they are integers. So therefore, this guy, they both are integers. Is that right? So therefore, what's going to happen is you just need to find out the integer between this range. You just need to find out the integer between this range and give the value for these two expressions, and you are good to go. Actually, there's only one integer between this range, and there's only one integer between this range. So easy, then you will be able to get A equals to 2, B equals to -7, C is actually equals to minus A plus B, which is 5, right? You see, easy peasy. You just try to use the very important definition, A, B, C, they are integers, and then they are squeezed into a specific range. You'll be able to find out the value for A, B, C, right? So as long as you have this, I think the following part will be very easy. The question asks you, if I plug in the value for F100, how can I find a value for K? So you just have to do a quick calculation. F100, just basically, you already know ABC, right? So F100 is 19,305. It's a crazy number. So in order to make sure 5,000 K is lesser than 19,305, is lesser than 5,000 K plus 1, you just do some calculation, do some trials and errors, you find out K is actually equals to 3. That's it. Easy peasy, right? Nothing too complicated, and you get what you need. The K is C part. See, very understandable. We're not using anything flowery, just basic stuff. Okay, if all good, let's go to one relatively difficult, but still very understandable problem. So the second problem, let's have a look at it. A problem that comes from AIME. We're going to increase the complexity a little bit. It's a problem from 2011, AIME 2, question number 9 part. So again, I'll give you guys maybe 30 seconds. Read the problem first. Okay, so let's have a look at it all together. The question says, let x1, x2, all the way to x6 be the non-negative real numbers such that, first condition I need to highlight it, x1 plus x2, x3, all the way to x6 equals to 1. Adding them together equals to what? Okay. And x135 plus x246. Okay. I have the odd term, put them together, the even term, put them together. Adding them together is greater or equal to 1 over 540. Okay, that's a little bit weird condition, right? Okay, but okay, it is what it is. Let P and Q are the relatively positive prime integers such that PM is the maximum possible value of this long expression 1, 2, 3, 2, 3, 4, 3, 4, 5, 4, 5, 6, 5, 6, 1, 6, 1, 2. It's kind of like a rolling, right? And then it's actually round off. Okay. So basically, let P and Q be be a positive relative prime numbers such that PQ is the maximum possible value of this guy. Find the value for PQ. So long story short, you need to find out the maximum value for this guy. Okay, I think this condition per se is kind of brief, right? The question gives you two conditions, a blue condition, a green condition. Blue is everything adding them together equals to 1. Green condition is 1, 3, 5 odd terms, 2, 4, 6 even terms. Adding them together, greater or equal to 1 over 540. And then ask you to determine the expression for this long, like the maximum value of this long expression. This long expression, I'll give a denotation. Goes like this. We let, because I don't want to write too much, right? This big thing equals to this bar, okay? So now, before we jump to the solution, let's try to think about it. What is the thinking process? How are we going to do with such a problem? Now, the question gives you a blue expression, a green expression, right? I don't even know where they are, but at least two expressions. And then ask you to determine the max value of this red expression. So this is something I know, right? This is something I do not know. So intuitively, our thinking process is, this is something I know, this is something I do not know. I need to find out what's the relationship between them, right? There's a gap, of course. And your goal is try to bridge the gap. So here comes like $1 million question. Is there any relationship between the blue one, the green one, and the red one? This is something, $1 million question, right? This is $1 million question. The blue one, the green one, or something between the blue one and the green, like whatever. What's the relationship between the blue, the green, the red? As long as you find out this relationship, I think we're actually moving to the correct direction. Correct direction. So this is actually a little bit challenging for this problem. As long as you figure out this part, the following part will just be a couple of lines. That's it. How can I find out the relationship from what I know to what I do not know? Or the most important thing is this red one, this long, nasty red one. How can I represent it using the green, using the blue, so on and so forth? This is actually a little bit challenging, and that's the only challenging part for this problem. As long as you figure out this part, you're good to go for the next part. Okay, I'll ask Wayne. Wayne has some ideas. So even though that's not the same solution, but I like invite students to show their ideas. Yes, go ahead, Wayne.
I might be wrong though, but
no worries.
So my strategy is so look at the red one and the blue one, and then I found out those two expressions, they both have 6 terms. So therefore, then we can construct maybe another thing. It's x2, x3, and then plus x3, x4, and then plus x4, x5, and then all the way go up to x1, x2. So that's also 6 terms. And then we call this maybe brown, and then we multiply brown, and then we use blue and brown to construct like a Cauchy-Schwarz. Yeah,
that's a very good idea. Yeah, we're going to use the Cauchy-Schwarz. We might go for this, but you're going to do a little bit of construction, which is perfect. Who else? Some other ideas? If I want to give you a quick hint, you see, what you have here is x1, 2, 3, 3, 2, 4, 4, 5, 6. They're actually rolling, right? One after another. But here is 1, 3, 5, 2, 4, 6. Is there anything I can do in order to just extract out 1, 2, 3, or 1, 3, 5, and 2, 4, 6? If I can basically find out something, I can just extract 1, 3, 5, 2, 4, 6. I might get what I need. This is actually a little bit challenging. In order to have this part, you can construct. So still, we're going to use a little bit of construction. Trust me, construction is going to be the buzzword. You keep hearing me talking in the entire inequality. You can do something like this. x1, x3, x5, right? So you have 3 brackets. Every one you take 1, 1, 3, 5. The other one, 2, 4, 6. You can make sure 1, 3, 5, everyone takes 1 term, it goes to here, and 2, 4, 6. Everyone takes 1 term, you go to here. Okay? Trust me, here comes the interesting part. As long as you open this entire expression, this is going to be exactly equals to green plus red. It's a magic, right? I construct such a thing, I just want to have my green, right? But as long as you open it, you're going to find out this one exactly equals to green plus red. This is the construction for such a problem. So one more time, I'm going to say x1 plus x4, x3 plus x5, x3 plus x1 plus x4, x2 plus x5, x3 plus x6, right? This guy will be exactly equals to my red expression plus my green expression. Okay? So this guy, my green is what the question tells me. This is greater or equal to 1 over 540. This is the question asking me to determine the max value. And this guy is what? This guy, don't forget, this guy is not blue, but this guy and blue, you have a very easy peasy relationship, right? From this guy to this guy, who can tell me what is the very conspicuous relationship? x1 plus x2 all the way to x6. And this is x1, x4 times x5, x6 times x3 plus x6. This is going to be exactly using what? Using the mean inequality. Is that right? So this guy, you can directly say is lesser or equal to 1/3 cubic, which is 1/27. Is that right? Lesser or equal to 1/3 cubic, which is equal to 1/27. So far, so good? Dude, this is actually something very easy, right? x1 plus x2, x3, x4, x5, x6 equals to 1, right? I'm going to change it into this, x1, x4, x2, x5, x3, x6 equal to 1. This is going to be a plus b plus c equals to 1. And what is ABC? ABC will less or equal to a plus b plus c divided by 3 cubic, right? Is 1/27. We use a little bit mean inequality, right? But not a complicated, super complicated mean inequality. So that being said, if you know everything in place, this guy will be written as your red expression. You want to ask for the max value, right? Plus your green will be lesser or equal to 1/3 cube. And don't forget, your green is greater or equal to 1/540. So therefore, your red will be lesser or equal to 1/27 minus 1/540, which is 19/540. That's it. This is going to be our P. This is going to be our Q. See, as long as you understand the construction process, you only solve the problem in one-liner. That's it. But of course, the million-dollar question is that you need to understand where we get such. The green one, the red one, the blue one. And find out the relationship between the three is going to be the most challenging part. So you see, this problem also has a little bit construction, but not huge, right? A little bit construction. As long as you get a hang of it, you'll be able to have an idea about it. So far, so good? Can I have some feedbacks? Are we all on the same page? Perfect. So I think 2 examples is good enough. This is more like our basic concept, using the inequality to do some calculation, right? And hopefully you get some expression value, maximum value, lower value, so on and so forth. This is basically using the property, using the definition, and we are basically good to go. Okay. By the way, a student asked me, are we going to talk about the mean inequality? Of course, mean inequality will be a very important part. Yes, but today we're just going to use it fairly quick, a very easy peasy application. But we're going to talk about it in more depths for the upcoming lectures for sure. Okay, if all good, let's go to our category number 2. Let's talk about something about the absolute value inequality. So let's go for a question first. So this is a problem that comes from 2010 AMC 12A, question number 22. Again, 30 seconds, read the problem first. Okay, so let's have a quick look at it. The problem says, what is the minimum value as an inequality of x minus 1? Then 2x minus 1, 3x minus 1, all the way 119x minus 1. Okay, there are 119 terms, right? One after another. What is the minimum value for such a guy? So first of all, I really have no idea how to do that, but let's do a quick comparison. We have already talked about the definition, right? The definition of absolute value, and taking from there, we understand the definition of the absolute value inequality. So let me ask you a quick question. If I ask you, what is the minimum value of such a guy? Let's say x minus 1, x minus 3, x minus 4, x minus 10. Who can tell me? Let's forget about this question for a sec, right? Let's step back a little bit. Let's go for an easy problem. If the question asks you, what is the minimum value of such an expression? Who can tell me? What's the value for that? Or what is the solution approach for such a problem? Who can tell me? Who can tell me? What's the minimum value for such a guy? Using the definition, we just mentioned the definition thing, right? Who can tell me? So I'm going to ask for Wayne.
Using the definition, so we have 1, 3, 4, 10 on the horizontal axis. So therefore, if you want to find the shortest distance of x to all those points, we just gonna let x stay between 3 and 4.
Is it right? It's very understandable, right? Because you want to find out where are the values. Let's say I want to make these two guys together, this guy plus this guy, right? And also these two guys together. Let's say for the black one, I want to find out a point which has the minimum value to 1 and 10. Of course, as long as my value is between 1 and 10, right? The distance sum will be basically equals to 9. Is it right? If x is between 1 and 10, the minimum value will be 9. Again, if you're asking me, how can I find out x minus 3 and x minus 4 to be the minimum? As long as I find something in between 3 and 4, right? I'll be able to make sure the minimum value will become 1, right? So this is minimum value 9. This is minimum value 1. So if the question asks you everything, what is the minimum value? You're going to find out the joint part, right? Of course, this is my part. As long as my x is between 3 to 4, I'm going to have my minimum value equals to 10, which makes sense, right? I think this is an easy peasy thing. Actually, you know what? We can make this conclusion more generic, a more generic solution. Conclusion. Let's say x minus 1, x minus 2, all the way x minus n. Okay, what is the minimum value? So this part we can actually give you guys a conclusion, which is kind of very understandable. First, if n is an even number, as long as your x is between n divided by 2 to n divided by 2 plus 1, because n is an even number, right? So n divided by 2 is an integer. You can find the minimum value. What about n as an odd number? If n is an odd number, then x exactly equals to n plus 1 divided by 2. You will find out the minimum value. Is that right? Means n plus 1 divided by 2 is x is right in the middle point. Let's say x is in the middle point. You're going to be able to find out the minimum value, right? If n is an even value, it's an even number, x is going to be in the middle range, right? You'll be able to find the minimum. But n is odd, x needs to be exactly the middle point to make sure you can have the minimum value. Which makes sense, right? This is not a rocket science. So in terms of what is the minimum value, you can do some calculation. But generally speaking, the minimum value will be either achieved in the middle interval, middle range, or right in the middle point if n is an odd number. Right? I think we're all on the same page. If this is general conclusion, can we use exactly the same thing? Try to find out what is the minimum value of this guy. This is what we do not know. This is what we know, right? We have already figured out this. Again, how can I find out the gap between what I know and what I do not know? How can I find out the gap between what I know and what I do not know? So this part, maybe you need a little tweak in order to make it happen. You see, previously when we were dealing with, they're all x minus this, x minus this, x minus this. But now you're giving me 1x, 2x, 3x, all the way to 119x. I'm gonna do a very quick change, a very quick tweak. My fx, I'll rewrite it into something like this. X minus 1, 2, x minus 1 over 1, 3, x minus 1 over 3, all the way 119, x minus 119. It's okay. I'm just gonna drag out the coefficient into here. So that being said, I think my question will be very similar to what I got as a conclusion. What I got is 1, 2, 3, all the way to n, right? Now it's a little bit different, but again, very similar. 1 minus 2, 1 minus 3, 1 over 2, 1 over 3, all the way to 1 over 119. But only difference is that this part you have 1 point. This part you have 2 points, 3 points, all the way 119 points. You have many points, not only 1 point, right? Let's say for this 1 over 2, you have 2 points. For this 1 over 3, you have 3 points. So that being said, if I put everything together into one horizontal line, can I just say in total, I have 1 plus 2 plus 3 all the way 119, which is equal to 7140 points. Okay, I'm just gonna, I know there are some kind of duplicity for the second, duplicate for the third. I'm just gonna expand everything. In total, there are 7140 points in total. According to our strategy, as long as you have an even number of points, there will be a what? There will be a range help you guys to achieve the minimum value. Is that right? So what is the minimum range? N over 2, n over 2 plus 1. So therefore, when x is between 35/70 point to 3571st point. In such a range, you will be able to find a minimum value. Is that right? Do you guys follow me? Can I have some feedbacks? Yes or no? Can I have some feedbacks? Right? Perfect. So that's the way how we convert. There are some duplicates, but I don't really care. I just want to expand everything into a big 1, 2, 3, 4, all the way to 190. There are 119. There are 7140 points. This is an even number. You're going to go for n minus 2, n over 2, and n over 2 plus 1. So within this range, you'll be able to find out the minimum value. Okay, but this is the point. This is the point. I need to find out the value. What is the value for this, right? What's the value for this? So that one is actually easy because 1 plus 2 plus 3 plus n equals to 75, 35, 70. I need to know which point is going to be my point, right? N is actually equals to 48, 84, excuse me, n equals to 84. So that being said, the 84th brackets, right? That's going to be my point. So therefore, the real range will be 1 over 84, 1 over 85. Is it understandable? Because I actually do a conversion. This is actually my points. This is 70, this is the 3570th point to the 3771 first point. But the point is not the value. I need to ask for value because the value is, see, 1 over 2, 1 over 3, 1 over 4, all the way. I find out whenever n is equal to 84, you just add up to the 3570th point. So that point is going to give you exactly 1 over 84 as the value of your range. This is a little bit confusing part you need to understand. So this is the range where you can have your x value. So that being said, as long as x is between this range, whatever value you choose is going to be always the same for the expression, right? So to make my life easier, I can let x equals to 1 over 84. You can do 85 or something in between. It's up to you. I just choose one value. That's it. So my goal is you need to add x minus 1, 2x minus 2, 3x minus 3, all the way 83x minus 1, 84x minus 1. Add, I'm just going to add here, 85x minus 1, 86x minus 1, all the way 119x minus 1. Why I'm saying this, don't forget, it's exactly the same thing. Because my x is equal to 1 over 84, so all the first 83 terms, they're negative, right? The first 83 terms, they're negative because x is less, right? My 84th term is exactly equal to 0. And my remaining 35 terms, they're all positive. Is that right? Very understandable, right? You need to know you have in total 119. In total, you have 119 terms, but you need to know which terms are positive, which terms are negative. That's the only thing you can get started, right? The first 83, because x is equal to 1 over 84, the first 83 will be negative. The number 84s will be 0. The remaining 35 will be positive. If we are all on the same page, the following part will just do some quick calculation. I'm just going to help you do this. Let's say the first 83, I'm going to drag it here. If everyone is negative, that's going to be 1 minus x, 1 minus 2x, 1 minus 83x, right? This is going to be your, if you remove the absolute value, you take the negative, right? So that one is going to be 83 minus x times 1, 2, all the way 83. Is it right? You know the value for x. X is 1 over 84. And the other part is doing some quick calculation. You do it by yourself. So I'll give you the value, 83 divided by 2. This part is equal to 0, nothing to say. Let's go for the last one. This part, everyone is positive. 84x minus 1, 86x minus 1, 119x minus 1. That one is going to give you x, 85, 86, 119, minus 35. Again, x is equal to 1 over 84. You do the calculation, 15 over 2. So the solution will be this guy plus this guy equals to 49. So this is going to be the minimum value of my long expression, which is 49. So far, so good. Are we all on the same page? I think this is understandable, right? So we just need to use the definition. What is the absolute value inequality? What is the definition of my absolute value inequality? You will be able to have it correct. So far, so good, right? Yeah, I think that's pretty much what I want to say for the second category, using some absolute value inequality. We already talked something at the very beginning of our lecture, so I don't want to unfold too much, right? Using the definition of the absolute value inequality, you'll be able to solve the problem. So normally in our advanced lecture, I'll give you AMC last 5 problems, AIME problems, Euclid problem, or some National Math Olympiad problem. Just try to reflect the complexity level of our current lecture. If all good, let's go to our last category. Our last category is, let's talk something about the construction. Number 3, construction. Construction, like I said, you need to create something from nothing. Like our second problem, right? We use the mean inequality to do a tiny construction. So like I said, construction method, we do not really have a black and white line. Always you want to do this. Always you want to do that. Sometimes it's kind of like a hybrid mode. You don't know what to do. You don't know what to get. The more problems you see, the more strategies you see, the more straightforward for you to come up with a construction. It handles like a dream, like I said. We're going to use the entire lectures series to talk about the construction. So let's go for one problem. This is a 2011 Chinese Math League problem. I think it's a CAM question. Let x, y, z are the real numbers. 0 lesser than x, y lesser than z, lesser than pi over 2. Please try to prove. Pi over 2 plus 2 sine x cosine y, 2 sine y cosine z, sine 2x, sine 2y, sine 2z. Let x, y, z are 3 real numbers. x is lesser than y, lesser than z, all of them between 0 and pi. Try to prove pi over 2 plus 2 sine x cosine y plus 2 sine y cosine z is greater than sine 2x, sine 2y, sine 2z. So trust me, this problem, if you go for the regular way, you want to use your inequality or trigonometry's identity, that's going to take you forever. Trust me, very complicated. There is a solution for that. You're going to use several pages to go for different inequalities, to go for different identities. But this problem has a very smart solution using the construction method. So let's think about it. Directly, if you want to go for the inequality part, if you want to go to the trigonometry part, like I said, this is going to be very difficult because, check it out. Here, sine 2x, if you open, will be sine cosine, right? Sine y, cosine y, sine z, cosine z. And then you do not really have all those kind of things, right? It's only sine and then cosine y. Sine y, cosine z, there's no way for you to do the allocation. So, do we have some more straightforward way to solve the problem? Construction is one of the very easy way, but I don't think you can directly go to the construction. Let me try to guide you a little bit. I like to guide you. Hopefully at a certain stage, you can give me some ideas. If I want to prove such an inequality, I just want to do a quick change. So the original inequality is basically doing something like this. Y cosine y, want to show, right? Want to show. 2 sine y cosine z, sine x cosine x, sine y cosine y, sine z cosine z, right? Okay, this is easy. I just open the double angle formula. There's nothing flowery, right? And then I'm going to do a division. Pi over 4. Right? There's nothing flowery. I just divide 2. Now I'm going to try to do some very quick similar terms. I want to consolidate some of the similar terms. Okay, these are like the basic similar terms. So that being said, I just want to show pi over 4 is greater than sine x, cosine x, cosine y, sine y, cosine y, cosine z. Sine z, cosine z, okay? I think all the way comes to here, I didn't do any magic, right? I just basically do some quick rearrangement, right? Now comes the $1 million question. This is actually a value, right? Like a constant value, pi over 4, okay? These are 3 kind of like 3 expressions. If I want to give you some hint, from the pure way how you want to do the calculation, I don't care. Can you convert the 3 expressions into the area of a shape? This guy, can you convert into the area of a shape? This guy, can you convert them into the area of a shape? As long as you can do this, this problem can be solved fairly quick. I'll give you maybe some time to think about it. Okay, this one is not easy. But I'll give you a hand, just kind of direction. Instead of doing the hard calculation, will take forever for sure. Can you convert it into some shapes? If you can convert it into some shapes, maybe you can solve the problem very easy. This is our construction. Michael mentioned the triangle. Can you elaborate a little bit? Wayne mentioned the semicircle. Can you also elaborate a little bit? I think that's actually very close. Like I said, construction handles like a dream. If you know the answer, you just have it out right away. Or maybe let me ask you another thing. When you see pi over 4, which is the most straightforward, your first reaction, what is that? What is pi over 4? What kind of shape might have an area of pi over 4? Wayne?
If we set the radius to 1, so pi over 4 just be a quarter circle.
Okay, a quarter circle. I'm gonna do a circle thing. Oh, oops, sorry. Okay, that's actually my quarter circle, right? Okay, I'm gonna maybe do a thing from here. Okay, let me try to find, this is here, right? This is here, it's only a quarter, right? I just wanna go for a quarter. Okay, so maybe that's the quarter circle. You can choose whatever. Okay, so as long as you have a quarter circle, these things, this, what they can be converted in. Let's focus on this first. This is my quarter circle, right? The first quadrant. Can I do something in the first quadrant and kind of like construct out the 3 black expressions? I'll give a hint, okay? I'll give you a hint. If I do something like this, I'm gonna do something like this, change different color. I'll say this is your X angle. This is your Y angle. This is your Z angle. Can you create something interesting using the sine X, cosine X minus cosine Y, so on and so forth? Let's focus on the first one. Can you tell me what does this guy mean? This part is a little bit difficult. It's the construction. Maybe I'll give you more hint. Let's have a look at it. If I create something like this, do you agree with me or not? Maybe I'll change a different color. My red, this is X, right? My red rectangle, let's give a name S1, okay? Red rectangle, S1. The area of S1 can be written as the height times the bottom, right? The height times the bottom. The height is what? The height will be directly sine x, right? And what is the bottom? The bottom will be this part minus this part, right? This part is going to be what? Cosine x. And this part will be cosine y. Check it out. This is exactly sine x times cosine x minus cosine y. Sine x times cosine x minus cosine y. Okay. If I already give you the hint number 1, who can tell me what does number 2 and number 3 looks like? So my red rectangle, which is S1, is exactly the first expression, sine x times cosine x minus cosine y, right? If I already give one hint, can you construct out the other 2 rectangles where the area can equal to the 2 other expressions? I'll give you some time. Think about it. Maybe I'm going to ask Wayne, what about my second expression?
So it's very hard to explain. So basically,
look
at the radius, the blue one that you draw in between. So it's actually the radius and the circumference of the circle. The touch point is actually the vertices of the top right vertex of the second rectangle, and then yeah, basically something like that.
Is it right? So my black one is going to be my second rectangle, right? And my let me change color. My yellow one is going to be my third rectangle, right? This is Y, this is Z. Because for my yellow rectangle, that's very easy. The height will be sine z. The bottom will be cosine z, right? And for my blue one, the blue one will be here. The height will be my sine y. And the bottom will be here, will be my cosine y, I've already done, minus this part. And this part is exactly cosine z. Is it understandable? So this is my S1. Let me give a name. This is S1, S2, S3. Is it right? So these three expressions are exactly the three expressions of my, like the three areas of my three rectangle. And the total area pi over 2 will be the area of my 1/4 circle. Of course, 3 S1, S2, S3, adding them together, the area is lesser than the 1/4 of the circle. So therefore, this guy is automatically QED. You see, this is very interesting. This is a very interesting construction, right? As long as you figure out what is the representation of S1, S2, S3, you'll be able to have the answer basically speak for itself. But of course, the $1 million thing is, how can you think about, I need to create S1, S2, S3 different rectangles? How can I think about the area of the 3 rectangles will be the weird 3 expressions? These really are the most complicated part. So that's the reason why the construction method, I might like to guide you at the very beginning. You learn something from me and then try to go for the remaining S2 and S3. No worries, this is only the first lecture. The entire lecture, I'm going to teach you guys how to do this construction. Okay, so far, so good? Are we all on the same page? Can I have some feedbacks? Are we all good? Yeah, if you don't understand, please let me know. I'll try to give you more explanations offline. Okay, if you have any questions offline, always talk to me. I'll be able to provide you the answers. All right, so that's actually a problem from China, right? Let's go for another Euclid problem. Like the last problem I'm going to be showing you guys is a problem from Euclid. I think this is also a very difficult construction problem. So I'm just going to give you the problem. Let's have a look at it, how this problem looks like. It's question number 9, Euclid, from the year 2011. Even though it's question number Y, but this is a very difficult problem. I think this number 9 is actually even more difficult than question number 10 for that same year. Again, 1 minute, I'll let you guys read the problem. Our problems covers the Canadian, American, Asian problems, so on and so forth. For question number 9 or even question number 10 from Euclid, even though it looks like scary, but for the A part and B part, sometimes, I think most of the time, A part is given for sure. B part might have some tiny things. C part might be difficult. So in a real exam, if you really do not have enough time, you can just give it up. Focus on the first 8 problems. That's going to secure your chance to get a certificate or even the honor roll. All right, so let's have a look at it, at a problem together. Okay. So the problem says let x Gauss, right? This is like the Gauss expression we have talked about so many times in our advanced function part. It's a Gauss function denote the greatest integer less or equal to x. For instance, 3.1, 3.1, if we take a Gauss, is 3, and the minus 1.4, take a Gauss, equals to minus 2, right? Gauss function and approximation is not the same. Approximation 3.4, let's say 3.1, if I want to take a Gauss, is equal to 3. 3.9, if I want to take Gauss, is also equals to 3, right? The greatest integer lesser or equal to x. Okay, suppose that I define the 2 functions, 2 weird functions, fx or fn equals to 2n minus a weird thing, take a Gauss. Gn is 2n plus a weird thing, take a Gauss. But these 2 weird things are actually the same. Actually, you know, this fx and gx or fn and gn, they're very similar, right? The only difference is one is here as a negative, one is here as a positive. Actually, from a mathematical perspective, we call it this is conjugated. Fx, gx, they're conjugated. Conjugated is actually a term we got from the complex number, right? Because we see I plus 1, 1 plus I, 1 minus I. These 2 complex numbers, they're conjugated to each other. But it's okay. This is only a definition, right? Like the question is not asking you anything for that. So question number 1, please try to determine the value for G 2001. I think this part is given, right? You just plug in the value for 2001 into G and then use your calculator to calculate the value, right? Euclid allowed you to use the calculator. So the first one is totally given, 4085. Nothing to say, right? Second part, try to determine the value for n for which fn equals to 100. Basically, number 2 is you need to find out the value for n such that this guy is an equation, right? So this equation equals to 100. How can I find out this guy equals to 100? Let's think about it. How can I find out this guy equals to 100? Of course, you know n is actually an integer, right? N is an integer. Think about it. Think about it. This is going to be integer, right? This is also integer, right? At the very beginning, you might have some fraction numbers, but this kind of like a Gauss function help you to chunk all the fraction numbers, right? All the decimals. Only make it as an integer. So that being said, if we do not do something super accurate, if we do not do something super accurate, let's say if I just remove this integer sign, I'm just going to do this 2n minus 1 plus equals to 100. If I remove the integer sign, of course, my value will be not exactly what I need for sure, but it won't be something too far away. Is it right? Because check it out. This is actually going to be an integer, right? This is going to be an integer. And then you subtract out another integer. You rendered an integer. If I remove this kind of Gauss function, this integer sign, there's no guarantee to be an integer, right? Also, this is not guaranteed to be integer. There might be some fractions, but generally speaking, you won't have something too far away because this is only be like the difference between this guy and this guy, just be the maximum. The difference, the maximum difference will be lesser than 1, right? They're not 200 away, 300 away, right? It's only the maximum is 0.999999. That's the maximum. So that being said, if I remove the Gauss sign, I just solve an equation like this. Of course, my value cannot be perfect, but it won't be too far away, right? I just need to find out some relatively close integers. You might get what I need. I don't know if you guys follow me, right? Because the difference between this expression and this expression is only 0.99999 maximum. This is not 2,000 like away or 3,000 away, right? So if I remove the Gauss sign, I'm just gonna have something fairly quick, fairly close. So trust me, this guy I think you know how to do, right? You can just do 2n minus 100 equals to 1 plus root. Right? You can basically do some quick analysis. 4n minus 201 equals to root 8n minus 7. And then you'd want to take a perfect square on the two sides of this equation, solve it, n equals to 55.47 or n equals to 45.43. Like I said, the difference between this guy and this guy is very minimum. It's actually lesser than 1. So that means that the n won't be too far away, right? So what you're going to do is you just have to verify any numbers close to this. You can verify 55, 54, 56, 45, 44, 46. Just try to do a quick verification, find out which one is correct. And you know what? Actually, you can find out 55 is the conclusion. That's it, right? Because these two expressions is very close to each other. So you can just close your eyes. Suppose this is not an integer, and then try to find out some close integers in between, and then you are good to go. I think generally speaking, you should be able to do the A part and B part, right? So far, so good. For A part and B part, I think there's not something too crazy, right? You'll be able to understand. Now, let's talk something about the C part. The C part is very difficult. I'm just going to take this opportunity to show you guys the solution. You get an idea how this question uses so much constructions. So the C part set, suppose A is actually a set. A has F1, F2, all the way F3, F2, F whatever. B is another set. B is also the G, G1, G2, G3, G2, whatever. They're all integers, right? Because don't forget, there's a Gauss sign here. Fx, Gx, they're all integers. A and B, they're nothing but a set of all the integers. That is, A is the range of A and B, and B is the range of, excuse me, A is the range of F, B is the range of G. Of course, right? You put 1, 2, 3, 4 up to whatever, they have all the range. Prove that every positive integer m is an element of exactly one of A or one of B. What does it mean? It means that A and B, if I give you any kind of integer, this integer must either in A or in B. Is that right? So this is like the meaning means every positive integer m is an element of exactly 1 or A. Means I give a number, this number either goes to A or goes to B. It can't go for B. It can't go for both, right? Either A or B. Every number, every positive integer must be either representable by A or representable by B. Okay, let's try to prove this. I'm going to give you the answer. This is a long, long answer, but I'll guide you how to read the answer. Okay. Give me 1 second. I'm going to drag it here. Let's talk about the answer. This is a crazy problem. So at the very beginning, we have already mentioned fx and gx are very similar, right? Fx is what? Let's go back. Fx is a 2n minus this guy. Gx is 2n plus this guy, right? They're very similar, they're conjugated. So I'm going to give this guy a name, k. Okay? I'm just going to give this guy a name, k. Okay? If this guy equals to k, that being said what? That being said means I take the Gauss function equals to k. The original function without having this Gauss must be between k and k plus 1. Is it understandable? The original expression without having this Gauss must be all the way from k to k plus 1. Okay? So that being said, you have a what? This is a inequality, right? Inequality has two sizes. The left-hand side is k, the right-hand side is k plus 1, which makes sense, right? So I'm going to do some quick simplification. I like to solve this inequality. So I times 2 on the two sides. This is going to be 2k. This is going to be 2k plus 1, right? And then I'm just going to try to do some perfect square, so on and so forth. All the way I can simplify to here. This is not a magic. I just basically do some simplification for this, right? I do a perfect square, I do some rearrangement, so on and so forth. Now, I'm going to do the number one type construction. The first construction. I'm going to do, you see, this is what? 1 over 2 k squared minus k plus 1. 1 over 2 k squared plus k plus 1. I'm going to define a sequence, tk. The general formula of tk is actually equals to 1 over 2 k times k squared plus 1. Okay, this is my construction. I just defined such a sequence. If that's the case, I'm going to be able to see my k minus 1 is going to be replacing k using k minus 1. Will be 1 over 2 k times k squared at 1 over 2 k squared minus 2. What I'm trying to do here, I'm trying to do is I'm going to change this part into tk plus 1. This part will be tk minus 1 plus 1. Does it make sense? I didn't do anything crazy. I just basically construct a sequence and then represent the original expression using tk, my k's term, tk minus 1, my k minus 1 term. So my original expression now goes to this. N is between tk minus 1 plus 1 and tk plus 1. Here, I'm going to do something very understandable. Because my n is lesser than tk plus 1, of course, I know my n, my tk, everyone is positive integers, right? So therefore, my n will be lesser or equal to tk. Is it right? This is like a basic property of integers. Let's say I have an integer a is lesser than b. Of course, a is lesser or equal to b minus 1. Because integers, they're discrete, right? They're discrete. So a is lesser than b, a must be lesser or equal to b minus 1. I think this is understandable, right? Why I'm doing this? Because previously this guy is positive, this one is lesser or equal to, but this guy is lesser. But as long as I do this quick change, this tk plus 1 will be converted into tk. So my n will be lesser or equal to tk minus 1 plus 1 to tk, right? The two sizes, they're both equal or lesser or equal to. Is this understandable? Are you guys following me? Yes or no? Are you guys following me? Okay, perfect. So let's continue. So here, this is nothing special. I just basically give an example. Let's say k equals to 1. This is between t0 plus 1 to t1. K is equal to 2. This is going to be t1 plus 1 to t2. Just give you some ideas. Okay. Now, the question is asking you to determine gx and fx, right? Don't forget gx and fx. So now I'm going to do the second time construction. Second time construction. I'm going to construct like a sequence R. The sequence R is actually be a set of integer greater than k squared and lesser or equal to k squared plus 1. This is totally my construction, my definition. So therefore, my RK will be equal to here, right? RK is from k squared plus 1 plus 2 all the way to plus 2k plus 1, right? This is going to be a k squared from k squared to k plus 1 squared. This is my RK. Okay, understandable, right? For instance, R0 equals to, there's only 1. R2 is only 3, right? R1 is only 3, and R2 is only 1, 2, 3, 4, 5, so on and so forth. It's a set which collects all the numbers greater than k squared and lesser to k squared plus 1 perfect square. This is my second construction. I'm going to do my third construction. SK. What is SK? SK is basically, you see, from k squared plus 2 plus 4 all the way plus 2k, kind of like all the even terms, right? All the even terms. All the even terms from k squared all the way to k plus 1 square, put them together into SK. And then I'm going to do my number 4 construction. QK. QK will be from k squared plus 1, 3, all the way to 2k plus 1. What is that? Also from k squared to k plus 1 square, but I'm going to take all the odd terms. So far, so good? So again, I'm going to give an example, so on and so forth. So that being said, here I defined, this is my RK. RK is from k squared to k plus 1 square, right? And from here, I'm going to put it into 2 parts. One is my QK. One is my SK. My SK is taking all the even terms. My QK is take all the odd terms. But QK and the SK, if you union them together, it actually equals to RK. Is that right? RK is from k squared to k plus 1 square. QK is only the odd terms, and SK is only the even terms. Okay? As long as you are ready, let's go for our goal. Our goal is try to define the Fn and Gn, right? Our goal. What are we trying to do? We're trying to do, what about Fn? What about Gn? The range. The range must be joined together, covers all the numbers, but there's no cross, no intersection between the 2 sets. This is where we come from, right? We already do 4 different constructions. Now it's time to do, let's have a look at it, how the F, how the G looks like. Let's have a quick look at it. Because previously we have already mentioned N is actually greater or equal to tk minus 1 plus 1, less or equal to tk. Still remember where we are? This is here. Okay, so therefore, this guy equals to k, right? This is our definition. We defined this from the very beginning, right? This is our definition. So that being said, I'm going to do something like this. my guy n is between from tk minus 1 plus 1 to tk. If I times 2, this is going to be 2, right? This is easy, right? I times 2. And then I want to add a k on 3 sides, on the at least the 3 terms, 2 sides of this inequality. So I add, this is actually equal to k, right? This is our k. Just add a k. And this is what? 2n plus k. This is exactly my gn. Is that right? This is my gn. So this part, do some quick simplification, is k squared plus 2. This part, do some quick simplification, is k squared plus 2k. And what is that? Still remember? K squared plus 2, k squared plus 2k. So exactly my gn belongs to my sk. Is it right? This is exactly from 2k, k squared plus 2, k squared plus 2k. K squared plus 2 all the way, k squared plus 2k. So my gn is actually between sk. I'm gonna put it here, okay? Gn between two sk. Gn belongs to sk. Then what about my fn? My fn, I'm gonna give you another page. This problem is very difficult. I don't think students can actually get an answer during the exam. So I just want to take this opportunity to show you guys the thinking process. So that one is, what is our second page? Yeah, that's our second page. Okay, we're done with the gn. Let's talk about our fn. So previously, I talked about this. N is between tk minus 1 to 1 and tk, right? So in this case, k is actually, n is equal to k. I mean, here we let like the value equals to k. What about I let k equals to k plus 1? So the entire expression is gonna offset by 1, right? The tk minus 1 becomes to tk, and the tk becomes to tk plus 1. And of course, at this moment, my k becomes to k plus 1. Still remember, previously this guy equals to k, but now I let k equals to k plus 1. So this guy goes to here. Is it right? I'm going to redo exactly the same thing. This is my expression. I'm going to time 2 on the 2 sizes. I'm going to add this guy, but this guy now equals to k plus 1. I want to add a k plus 1 on the 2 sides of this equation. So that one will be exactly your fn. That one will be k squared plus 1. That one will be k squared plus 2k plus 1. Is it familiar? Go back to C. K squared plus 1 all the way to k squared plus 2k plus 1. So therefore, from here you can see fn is actually belongs to qk. Is it right? Voila, as long as you come to here, you're good to go. Because we have already proved that our rk is actually any number from k squared to k plus 1 squared. It covers all the integers. And it can be segregated, can be divided into 2 parts. The odd part is qk, and the even part is sk, right? And now you just proved your gk actually belongs to the even part. And your fk or fn actually belongs to the odd part, right? So therefore, your fn and the gn, they cover all the integers from k squared to k plus 1 squared, and also fn, gn, there's no intersection. So that being said, the question asks you to prove if I give you any number any positive number, it either goes to Fn or goes to Gn. Of course, one is positive, one is odd, one is even, right? Of course, there's no way to be them to be set to be overlap. So this is exactly what the question asks you to prove. This is QED. Oh, this is a very difficult problem. Like I said, it's even more difficult than the same year question number 10, because you need to do the construction 4 times to make it happen. So this is a super difficult problem. I don't think any student can do it by themselves directly. You need to construct 4 times. But at least I want to give you guys an idea how the construction works. Construction, like I said, it handles like a dream, and you have to create something from nothing. But no worries, the last problem is very challenging. If you don't follow me, no worries. And this is a difficult problem, but generally speaking, I want to give you guys some difficult problem for our advanced lecture. This is our Hawk class, right? If you go to our lower class, right, that's going to be way easier. But again, just want to give you guys what is the thinking process for this. All right, I think that's pretty much what I want to say for our today's lecture. I'm going to give you the assignment right after our lecture. You'll be able to have access to it. Also, if you have any questions or something, you can reach out at me offline and I'll be able to provide you all the information. Our lecture has you can actually ask for recording of our lecture. You can actually review it thereafter. Okay. Yeah, I think that's pretty much what I want to say for today's lecture. You have any questions for me? All good? Perfect. In that case, I wish you guys a good weekend, long weekend actually. I'll see you guys for the next Saturday. Bye guys, have a good one.